Okay, we're going to be debunking Susan Solomon's claim about ecological tipping points being fear-mongering. She gave a talk last year about her new book, and this was just recommended by Professor Raymond Pierre Humbert in the talk he just gave yesterday, or that was uploaded yesterday on YouTube. And basically, she's promoting renewable energy to solve global warming. And when she was asked about ecological tipping points, she said they were fear-mongering. And when she was asked about the Arctic methane, she said that this is not really an issue because of a study that proved that when the abrupt warming happened at the end of the ice age, there was no significant release of Arctic methane. So we're going to challenge her claim that that's the case. So what happened was, well, she also said in that talk that the Inflation Reduction Act was, since it's an act of Congress, it cannot be reversed by executive order. So Earth Justice just filed a lawsuit to reverse the executive order that the Trump fascist regime did to freeze the Inflation Reduction Act for renewable energy. So hopefully that lawsuit will be successful. But she obviously underestimated the corporate fascist in the U.S. empire. And in that same talk, she said that the 30% of global energy is now renewable, but she actually meant electricity, not energy. In my last talk, I already went into the limitation of renewable energy in terms of global warming as per William Rees's published study on the carrying capacity of ecology. So now we get to the Susan Solomon's claims on abrupt eruption of methane not being an issue, being a fear-mongering. So she's citing a 2017 report. And the study came out ironically the last time the Arctic was at a record low. So we are just now at a record low Arctic ice that was lower than the 2017, which is the previous record low. And so at that time in 2017, there was a big concern about the release of the Arctic methane. And so now we can look at new studies that revisit that concern. So the study she's citing says that when you had this abrupt warming at the end of the ice age, results show that the natural marine methane hydrates are 20% or less from the rest of the methane release. And so the methane release was driven by wetlands and not any kind of stored up hydrates. And so that would put to rest the idea that methane hydrates could be an abrupt eruption. And so it has remained in the IPCC reports. So the oil industry then kind of backfires because they want to claim that natural methane is higher, so they have less of their own methane as a source compared to natural methane. So that's an understandable debate in the science in terms of the oil science versus just normal science, corporate junk science. So the normal science says that 25% of methane emissions are not natural. They're from industrial sources or agriculture. Okay, so now we can see why they are assuming just a slow release of Arctic methane. They're citing that the earlier estimates by Natalia Shakhova's research group have been subsequently revised substantially downwards by numerous recent studies. So we're going to be looking at these recent studies. This is Tohima was part of an international research expedition to corroborate Shakhova's research. And so here was that study estimation of methane emissions from the East Siberian Arctic Shelf. And so based on that study, the range was substantially revised downwards from 0 to 4.5 a year. I'm not going to get into the units because I think it's like teragrams or something like that. So then we can find marine methane hydrates in the Arctic, a non-tipping element, just like Susan Solomon said. So she's been corroborated according to mainstream science as of 2020. But is that really true? Has that really held? Now, first of all, we have to realize that the current CO2 emissions are way higher than the previous ice age cycles. They're like twice as high. So that would indicate that even though the 90% of the heat has been stored in the oceans, that's going to lead to much greater melting than the previous ice ages. So that right there challenges this first study that you're just relying on the previous abrupt warming of the end of the ice age as your measurement point. So that's right away we're in problematic territory. You know, if we're just going to rely on that, obviously that's ignoring the ocean heat content, which is the big point of oceanographer Jim Massa. Okay, so we have shown that current magnitude of thaw has not yet exceeded previous deglaciations, but that permafrost carbon release has the potential to exert a strong feedback that exceed those of the Pleistocene, the ice ages. Some view permafrost as a rather stable or only slow reacting component on the timescale of thousands of years, resulting in minimum feedback to the climate. With atmospheric CO2 reaching 420, it's probably higher than that now, right? Values not last observed in 3 million years, we can expect it to reach concentrations not observed in 30 million years by 2300. Now that could go much higher, but the thing is like these permafrost carbon dynamics are not even included in the IPCC. So that's just for the permafrost, but we're looking at the subsurface permafrost. Okay, so paleopermafrost, it contracted during the interglacials, and then high rates of thawing, but the methane hydrates remain stable, so it shouldn't be a problem, right? So focusing on the abrupt warming during the deglaciation, we find that the methane release is driven by the wetlands, and the variation in atmospheric methane is small, but not negligible. Okay, so the question is, how did Shakhova respond to these studies? This is my question. Compiled observation data suggests that subsea permafrost might be a major organic matter source to the Arctic Ocean, which could release tremendous carbon upon remineralization. So this is a study by Chinese scientists, and they're saying, so you have these subsurface permafrost. Now this is still organic origin of the carbon. Given the huge amount of organic carbon stored in the subsurface permafrost, it's not the same as the pressurized hydrates, the frozen preformed methane. But they're saying that even when you consider that there's a high amount of preformed carbon that would, and this is a greater threat for global warming, that because of the fast ongoing Arctic warming. Okay, so the current thawing, but the mainstream science is claiming that even if that organic methane gets released, it'll get neutralized by bacterial decomposition that neutralizes the methane in the water before it gets emitted as methane. Constraining emissions due to thaw, suggesting that large permafrost carbon pool is largely insensitive. Okay, so now we got to look at the preformed pressurized methane directly, because that's the real issue here. That keeps getting ignored. Nevertheless, there are huge uncertainties regarding the composition of these cryosphere carbon pools. Okay, the lack of understanding creates the largest uncertainties to cryosphere climate carbon couplings. The vast yet shallow region has recently been shown to be a significant modern source of atmospheric methane, contributing no less than the terrestrial Arctic ecosystems, which is comparable to the methane emission of the United States. Several sites drilled 30 years ago were recently redrilled, which revealed the thaw horizon has been moving down several meters, so they're proving that this is working its way down to the subsurface pressurized methane. So here we get a 2024 study. Surface networks in the Arctic may miss a future methane bomb. So sure enough, Shakhova's research is not being just dismissed as scaremongering, fear-mongering. Future estimates suggest that around a 50 gigaton of methane could be released from gas hydrates alone over the next 50 years. And the continuous leakage of an old geological reservoir and perforations in the subsea permafrost, serving as conduits of deeper methane to gas-charged shallow sediments. So these releases may be more eruptive in nature, which provides a larger potential for abrupt future releases. So this is the updated research of Shakhova with Julia, what's her name? Oh, I didn't get the link updated. Let's see if let me try. Julia Steinbach. I should have the link in here. I kept reloading it. Here we go. Oh wait, is that it? No. Yeah, there it is. So this is the Steinbach with Shakhova 2021. So we're looking at the East Siberian Arctic Shelf, and this is the largest ocean shelf in the world, and it's shallow. So then you have this deep preformed methane and thermogenic gas and gas hydrates. And these two sources are preformed, and then they can fracture and release. And so this is the real big concern. It's not the microbial methane production. Okay. So the source apportionment of methane escaping subsea permafrost system. The triple isotope fingerprinting suggests, however, that methane may not primarily originate directly from the subsea permafrost. The continuous leakage of old geological reservoir to the water column suggests the existence of perforations in the subsea permafrost, serving as conduits of deeper methane to gas-charged shallow sediments. Second, the finding that methane is released from a large pool of preformed methane as opposed to methane from slow decomposition of thawing subsea permafrost organic matter suggests that these releases may be more eruptive in nature, which provides a larger potential for abrupt future releases. So they're proving that this is occurring already, this deep formed, in direct contrast to the claims of Susan Solomon, who's dismissing the Arctic methane as just being based on the ice ages as wetland from the wetland source. Okay, so we just disproved Susan Solomon's claim. Now we will continue on to see. Okay. So continental margin sediments contain large reservoirs of methane stored as gas hydrate. Ocean warming will partially destabilize these reservoirs, which may lead to the release of substantial yet unconstrained amounts of methane. Okay, so this results. The results imply an extremely low mitigating effect of anaerobic oxidation of methane. This methane could cause an abrupt transition into a warmer climate state, although crossing such a threshold is deemed highly unlikely within the next century. So this study is admitting that yes, it is a threat, but they still think, oh, it's probably not going to happen. So they're admitting the existence of this methane that is releasing. They are admitting that it will not be neutralized by bacteria eating the methane. As a result, the permafrost methane feedback may be much more dangerous than suggested by studies accounting for microbial methane alone. So that was a big issue that Susan Solomon was referring to, a study that supposedly just accounted for microbial methane because it's just the permafrost, the Pleistocene ice age cycle, and doesn't tap into this deeper gas hydrate. So what is this study showing? A proportion of thermogenic methane in addition to the dominant microbial methane was found in gas emission craters in western Siberia. So basically in 2020 there was this huge heat wave in Siberia, and this study proved that just like in the East Siberian Arctic Shelf, the isotopes were consistent with a old deep thermogenic methane. Our observations hint at the possibility that permafrost thaw does not only release microbial methane from formerly frozen soils, but also and potentially in much higher amounts thermogenic methane from reservoirs below and within the permafrost. Gas hydrates are in the permafrost are estimated to contain 20 gigatons, Additionally, subpermafrost natural gas reservoirs may be tapped. So they're actually saying with these subpermafrost natural gas reservoirs, there's about 1,200 gigatons of, well, that's 20 gigatons of carbon. So that's after they convert the methane. Okay, so there's a way more methane in the subpermafrost. Okay, so we've proven that the subpermafrost methane is already happening, and it's proven to be increased during heat waves, which is their big concern, is that this would be a larger potential for abrupt future releases. It may be more eruptive in nature, these releases. So that's the big problem here. Yet unconstrained may lead to the release of substantial. Okay, so may be much more dangerous than suggested. So we can just say it may be a real big threat in the near future. We can say that's scientifically proven.